will be applicable. This effect will be applicable throughout the magnitude plot. Next, we have net slope as minus 20 dB per decade and frequency range is initial to 2. Okay. So now we have considered 0.1 as our starting point. This can't be 0 because 0 frequency has no meaning. So we have to start it with 0.01 or 0.001 or 0.1 depending on our problem. Usually we start with 0.1. So now what initially we do is, for sketching the plot, we need the lines of minus 20 dB per decade, minus 40 dB per decade, minus 60 dB per decade, plus 20 dB per decade, whatever it might be. So for that, we are supposed to draw the reference lines. Okay, this 0.1 to 1 is 1 decade, right? And if the magnitude changes from 20 to 0, this line would be called as minus 20 dB per decade line. Okay, and that is why I have just shown the dotted lines. Can you see the dotted lines here? Okay, so this is minus 20 dB per decade dotted line, minus 40 dB per decade dotted line, 40 to 0, and minus 60 dB per decade with a dotted line. These are just the reference lines for plotting the magnitude. Okay, now let us start understanding how to actually sketch it. So from your magnitude table, first thing that should be drawn is minus 20 dB per decade line from initial point to frequency 2. Okay, now look at the frequency. This is frequency 1, and suppose here there is frequency 2. On semi-log paper you will find it written. Okay, what is 1, 2, 3, 4, whatever it is, you will find it written. So up to 2 you should be sketching, this is the point, up to 2 you should be sketching a line with minus 20 dB per decade slope. So that is why I have drawn it up to 2. Now suppose the initial frequency or corner frequency would have been 3. I would have continued this up to 3 depending on the last column in my magnitude table. Okay, so now minus 20 dB per decade up to 2. The next thing that you should do is minus 40 dB per decade from 2 to 5. Okay, so from 2 to 5 we have minus 40 dB per decade line. Now how did I draw this line, do this line? I have a reference line here. Okay, यहाँ पे एक minus 40 dB per decade का reference line है. I'll use the roller scale and I'll draw a line parallel to this line from 2 to 5. I have considered this value to be 5. Okay, so from 2 to 5 minus 40 dB per decade line. From 5 to 10, next thing, from 5 to 10, again the slope changes back to minus 20 dB. So again, a parallel line to this minus 20 dB per decade, but from 5 to 10. So this is again minus 20 dB per decade line. And last thing in your magnitude table, last row, minus 40 dB per decade, 10 onwards. So again minus 40 dB per decade को parallel line draw करनी है. After 10 up to infinity, you can continue it, right? So this forms minus 20, minus 40. Please don't forget that the slopes are per decade, okay? And these are the reference lines that we have drawn. Now, once magnitude plot is ready, okay, this magnitude plot is for k is equal to 1. But in our problem, we have k is equal to 10. That means 20 log of 10 is equal to 20 dB. So this whole graph is to be shifted upwards by 20 dB, and that we can do at omega equal to 1. Now, what is the significance of this omega equal to 1? At omega equal to 1, the magnitude is 0 dB. How? Magnitude would be 20 log of omega. Okay, and 20 log of omega, when omega is 1, gives you 0 dB. So that is why your magnitude plot crosses 0 dB at omega equal to 1. Okay, so यहाँ से हम अगर if you just see 20 dB upwards and then shift the graph parallelly, please don't change the slopes and corner frequencies. Okay, you need to be careful while drawing this. Slope should remain same, frequency should remain same, only the magnitude should be changed. You are shifting it upwards by 20 dB from this reference point at omega equal to 1. It doesn't mean that at this point it shouldn't be shifted by 20 dB. Everywhere it will be shifted by 20 dB. But as a reference point, we consider it from 0 dB to 20 dB just for the convenience. Okay. So we have a point here, and then we can draw 20 dB, minus 20 dB parallel line up to 2, then minus 40 dB up to 5, then again minus 20 dB up to 10, and then 10 onwards. So these two graphs are parallel to each other with different magnitudes. Here the magnitude in dB is 0, and here the magnitude in dB is 20, depending on the value of K. I hope this is clear to you now. Now let us come to the base.
Excuse me, ma'am.
Yeah, just a minute.
Excuse me, ma'am.
Yeah.
Ma'am.
Just a minute. I can't hear you properly. Yeah.
Ma'am, now can you hear me?
Yeah, but many people are speaking at a time. Ishita?
Ma'am, I'm there. Ma'am, I'll type in the chat section.
Yeah, sure. Yeah, rest everyone, have you understood this? Please unmute yourself and let me know.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay, Ishita, you are asking some doubt. We have to shift. Yeah. Shift it with the help of roller, because initially you have sketched the reference point, right? Reference graph. Just drawing it with roller, just shifting upwards and then drawing parallel lines. That should be sufficient. So roller scale is important, and please use pointed pencils, because that also change the value of GM and PM, as we will see further. Okay, so shall we continue now? Phase plot.
Ma'am, I have one question.
Yeah, please.
Do we need to write that formulas, that calculation for magnitude table, or only
magnitude table and phase table have written on the paper, because you will get marks for those magnitude table and phase table. Sketching of Bode plot have less marks than actually calculated, right? So you are supposed to first prepare magnitude table and phase table, as I have done yesterday, stepwise, and then you should sketch it as we are seeing today. Okay.
that calculations for magnitude table is not needed? Only that magnitude table having 5 contents, that is sufficient.
Which one?
While in the paper, that calculation using that log formula. 20 log.
No. Okay. Calculations using log formula will not be needed. That was the understanding part. You have understood how to prepare the magnitude table. Yesterday, we also have seen what is the slope contribution by each factor, right? So if you
Yes.
should be able to prepare the magnitude table easily. And
Yes.
previous part, formula wala part, 20 log of omega t, 20 log of k, that is for your understanding. For at least for value of k, you need the formula. At least for k, you need the formula 20 log of k. Okay. Abhijit,
Yes.
is that okay?
Yeah, it's clear.
Okay. So now let us go to the phase plot again. Okay, so now this is the phase plot. Please understand, this phase plot is a smooth curve. It is a smooth curve. I have drawn this particular curve from the phase table. Okay, phase equation we have written yesterday, and by substituting various values of omega, we calculated the phase. So it should be drawn in the normal way with which we draw the graphs. Okay, so it is a smooth curve, and the magnitude plot has angles, corners, as you can see. So this plot is known as asymptotic plot, and this is a smooth curve. Okay, I hope you understand the difference. Now, why this is called as asymptotic? You remember the definition of asymptotes in root locus. Asymptotes are the lines which go to infinity, right? So in this case, what is the significance? If suppose now we have one factor and its effect is running up to this point, okay, if another factor hadn't been there, this line would have continued up to infinity, but due to another factor which started contributing at this value, then the slope changed. Okay, same is the case with this. This would have continued up till infinity, but this factor started contributing at 5 at next corner frequency. And that is why there are corners like in your magnitude plot, and that is why it is known as asymptotic plot. Okay, so this is just a smooth curve that we have, that we plot using the normal way. You can take a look at the units or scale that I have taken here. Okay, this is the standard conventional one. You can change it as per your convenience, but I have drawn it, I have written it, the conventional one which works for most of the problems. Okay, so after doing so, now the next thing is we need to calculate gain margin and phase margin from the magnitude plot and phase plot. I hope drawing this is clear with you all. And yeah, so now the next thing is when we actually see how to calculate gain margin and phase margin from the magnitude plot and phase plot. As we are running out of time in this particular meeting, I'll have to reschedule a new meeting with you all. Just let me know whether 10 minutes gap is sufficient for you. After 10 minutes, you will re-log in. I'll send the new invitation link to you. Is that fine?
Yes, ma'am, it's fine.
Okay, everyone?
Yes, ma'am.
Yeah, so Shivam, I'll share, but the gap would be all maximum up to 10 minutes. So please be online.
Yes, ma'am.
Okay. All of
I
you
will
can
do.
now. I'm sharing a new link with you.